Here we have AP calculus AB problem. Okay, let's go to the question. Find the indefinite integral. Use C for the constant of integration. Here we have an indefinite integral and we have to evaluate this indefinite integral. Okay, now let me consider the particular part of the function that has to be integrated over here. That is square root of tangent of 3x. So this is a troubling part in integration process because here we have square root. Inside the square root we have trigonometric function tangent and the angle is multiplied by 3 over here. Instead of this tangent 3x, if I just have a single variable inside the square root over here, so it will make the integration process easier. So at the place of tangent 3x inside the square root, I just need a single variable. So what do we have to do for that? We have to assign a new variable for this tangent of 3x. That's called u substitution. Okay, now let me start this problem with u substitution. That is, I'm going to substitute a new variable u for this particular stuff. That is tangent of 3x. So when I substitute the new variable u for this one, then I'll be getting square root of u. So I may get a chance to integrate this one easily. Okay, since I substitute a new variable u for a part of the integrand over here, I have to get the complete integration in the new variable u. Since I'm going to get a complete integration in the new variable u, instead of dx, I must be getting du so that I can integrate with respect to u. So at the place of dx, if I want to get du, what should I do with this u? I have to differentiate. Since we have the original integration with respect to the variable x, now we have to find derivative on both sides of this equation with respect to x. Okay, now let me find derivative on both sides with respect to x. When I find derivative of this u with respect to x, I'm getting du over dx. And when I find derivative for the tangent function, it will become secant square of whatever stuff I have here. It has to be written as it is. So far I have completed derivative only for the trigonometric function tangent. By chain rule, I have to do further derivative for this 3x with respect to x. When I do derivative of this 3x with respect to x, I'm just getting 3 because I'll keep the constant 3 as it is. When I find derivative of this x with respect to x, it will just become 1. 1 times 3 is 3. That I'm getting over here. Now du over dx equals to, we can write this 3 in front of the secant square of 3x over here. Then I'm getting 3 times secant square of 3x. Okay, now my aim is to solve for du in this equation. For that, I have to get rid of this dx in denominator. So for that, I multiply both sides of this equation by dx. Then dx will cancel. I'm getting du equals to 3 times secant square of 3x times dx. Okay, when I consider the stuff over here in the given integration, so for this one, we can substitute the new variable u. And for this one, we have to solve. Already, almost I solved for this stuff. But here the problem is that 3 is multiplied over here. That is comparing this and this. So to solve for the secant of 3x the whole square times dx, I have to get rid of this 3. For that, I have to multiply both sides by 1 over 3. Let me do it. So when I multiply both sides by 1 over 3, this 3 will cancel out. I am getting 1 over 3 times du on the left side. And this secant square of 3x can also be written as a secant of 3x the whole square times dx. Now I got this stuff exactly over here. That is equal to 1 over 3 times du. Okay, now let me go to the integration. So it is equal to integral square root of. So for this tangent 3x, we can substitute u. Then for this stuff, already we got the stuff that is equal to secant of 3x the whole square dx. That is 1 over 3 times du that we can write over here. Okay, now when I consider the stuff over here, this is a part which contains variable and this complete variable part is multiplied by the constant 1 over 3. In integration, when the complete variable part is multiplied by some constant, we can move it out of the integral. That is the constant 1 over 3 can be moved out of the integral. Then I'm getting integral square root of u times du. 1 over 3 times integral. Now to integrate the square root of u, what I'm going to do is I'm going to write the square root as an exponent. Whenever I write square root as an exponent, it will be 1 over 2 times du. Okay, 1 over 3 times. Okay, now we can integrate this one using the power rule of integration. That is, we have to add 1 to the exponent and divide the result by the same exponent. That is u to the power of 1 over 2 positive 1 over 1 over 2 positive 1. Actually, this is indefinite integral. That is, we don't have the lower limit and upper limit. In integration, whenever we don't have limits, then it is called indefinite integral. When I evaluate indefinite integral, always I have to add the constant of integration to the result of the integration. Actually, this is the result of the integration over here. So I must add the constant of integration to this result. So the question says use c for the constant of integration. So let me add this c as constant of integration over here. That is positive c. Okay, now let me continue over here. 1 over 3 times u to the power of 1 over 2 positive 1 can be written as 3 over 2 over, so the same thing, 1 over 2 positive 1 will result 3 over 2 positive c. Okay, 1 over 3. And now what we can do is, if I move this fraction, actually this fraction is in denominator. If we move it to numerator, we have to get the reciprocal of this fraction. Then I'm getting 2 over 3 times u to the power of 3 over 2 positive c. So 1 times 2 is 2 and 3 times 2 is 9. Then I'm getting 2 over 9. And u is a variable taken by us. Now it has to be replaced by the original stuff, that is tangent of 3x. Then I'm getting tangent of 3x raised to the power of 3 over 2 positive c. So this is the result of the given indefinite integral.